a field hospital in Crimea, a clock with 2 minute hands, a tunnel under the River Thames, a pipe with a slot along the top, and a small railway station in Oxfordshire. These are some of the lesser known parts of the story of an exceptional engineer. Our story starts in London in 1824. An already famous and successful engineer, Mark Brunel, was attempting to build the first tunnel under a navigable river, here at Rotherhithe, and the river, of course, the busy River Thames. His son, Isambard Kingdom Brunel, then aged 18, was working with him and was already a key contributor to the project. The tunnel construction method was untried and dangerous. When the roof collapsed, men were killed, and Isambard, who worked as hard as anyone, was seriously injured. There were many more setbacks, but Mark finally completed the tunnel in 1843 and to great acclaim. But this was long after Isambard had moved on to other things. The nearby Brunel Museum, part of the original tunnel works, serves as a reminder of the Victorians' determination to succeed. The tunnel itself, which links Wapping and Rotherhithe, well, it's still in use every day, only now as part of the London transport system. Following his accident, Isambard was forced to leave the tunnel works and convalesce. He went to Bristol, a city destined to become pivotal in his engineering career. But resting did not come easy to him. Throughout his life, he was a workaholic. When he heard about a competition to design a bridge to cross the River Avon, it fired his imagination and he was determined to win. He submitted 4 designs and won. It became what he later referred to as "my first child, my darling." Although he was appointed chief engineer of the project, he was fated never to see the completion of his beloved bridge. Having built only the supporting piers, the trustees ran out of money and work stopped. It was not finished until after his death, when the Institute of Civil Engineers completed the iconic Clifton Suspension Bridge and dedicated it to his memory. Like the Thames Tunnel, this bridge is also still in constant daily use. He was also employed as chief engineer for the Bristol Docks Company, where he created this lock, now heavily silted with mud, to improve access to the then busy Cumberland Basin. The wrought iron footbridge, built to cross the lock, is significant in that it's an early prototype of some of his grander designs, like this railway bridge over the Thames, built to carry a branch line to Windsor. In fact, his most memorable and lasting bridges were designed as part of his lifetime career in railways. In 1833, the merchants of Bristol, importing mainly tobacco and wine, realised that in order to stay competitive, it was vital to have a rail link to London. And so the Great Western Railway, later known affectionately as God's Wonderful Railway, was born, and Isambard Kingdom Brunel, now at the great age of 27, was appointed chief engineer, tasked with building this new railway. The route ran west from London and followed the Thames Valley. To speed completion of the project, a simultaneous start was made from Bristol and the lines met at Box Tunnel. The tunnel was an unprecedented 2 miles long, and when the two sides met, they were out by just 1¼ inches. Brunel was indeed a perfectionist. His designs were not only functional, but, as this bridge at Maidenhead shows, elegant. He pushed the boundaries. It was the widest unsupported brick arch ever built, and critics said it would collapse. Well, they were wrong. Over 170 years later, it's still standing and still carrying the Great Western Main Line to the west of England and Wales. As well as bridges, the network needed viaducts, and this splendid 9-arch example at Chippenham shows the master engineer at his best. When it was built, there were no proper roads below, only dirt tracks, and people must have been awestruck by the iron monsters passing overhead. Of course, key to the successful running of the railway were the stations. The line started at Paddington, and Brunel's magnificent London terminus retains his elegant glass and wrought iron roof, which was inspired by the Palm House at Kew Gardens. And under what was his office overlooking Platform 1, Mr. Brunel still keeps an eye on the 34 million passengers who use his station every year. At the Bristol end of the line, he built the first ever multi-purpose rail terminus. At Bristol Temple Meads, he provided a passenger shed, engine shed, goods area, workshop and offices. He created separate arrivals and departures by using arches at either side of the building. Now only this one arch remains. This Grade 1 listed building is currently undergoing restoration, but we can still see a little of the original hammer beam roof. What is now a car park gives us some idea of how the station would have looked before it was replaced by the current Bristol Temple Meads station. For the small country stations, he created a standard design, which was known as the Pangbourne. The last remaining example is this one in the village of Culham in Oxfordshire. Brunel was not only interested in practicalities, he wanted his passengers to enjoy a smooth and comfortable journey. To achieve this, he minimised the gradients of the track, and the line became known as Brunel's billiard table. He used larger wheels and, whilst most railway companies used a track width of 4 feet and 7 inches, known as standard gauge, he adopted a width of just over 7 feet, known as broad gauge. His reasoning was that the larger wheels and the broader gauge would provide a smoother, faster journey, which it certainly did. The problem came when it was necessary to switch passengers between the two gauges. Changeover sheds, like this one at Didcot, were used, but proved to be chaotic. The alternative of combining the two gauges within one track was expensive and complicated. Eventually, a Royal Commission, whilst agreeing that the broad gauge was superior, ruled that the country needed a unified track. As there was considerably more standard gauge, the broad gauge had to go. Oddly enough, there was also a problem with time. Each town set their local time based on longitude. This didn't matter with slow stagecoach travel, but it caused havoc with the timetables for the much faster railways. Brunel's Great Western Railway solved this by standardising their timetable to London time. However, Bristol Corporation was not happy with this and responded by fitting 2 minute hands on the Corn Exchange clock, showing both London and Bristol times. You could be forgiven for thinking that Brunel would be feeling content with what he had achieved. Far from it. He had a grand vision. Journey from London to Bristol and on to New York. And with this in mind, he designed and built 2 impressive ships, the Great Western and the Great Britain. And he later built a 3rd ship, the Great Eastern, designed for passage to Australia. Sadly, neither the Great Eastern or the Great Western, with which Brunel's transatlantic grand vision finally became reality, still exist. On the other hand, although she had a somewhat checkered career, the SS Great Britain has survived. Now beautifully restored, she is berthed where she was built, here in Bristol's Great Western Dock. As with everything he did, Brunel designed something of great strength, but elegant and detailed. SS Great Britain could carry over 350 passengers with a crew of 130 and 1,200 tons of cargo. Unlike today's cruise ships, there is almost no superstructure, which meant there was plenty of room on deck for passengers to walk and take the air. Below, there were 2 passenger decks, and here we see the promenade deck, which could be used for exercise when the weather prevented passengers venturing onto the open deck. Daylight from the deck above is used as borrowed light to illuminate the dining room below. This is where the first-class passengers dined, and with its long tables, beautiful pillars and mirrored doors, it's easy to understand why Queen Victoria was most taken with this room when she visited the ship. By contrast, the cabins were very small, with only the most basic of amenities. The ship's massive engine rises through 3 decks and is situated midships. In order to connect the engine to the propeller shaft, Brunel had to design this powerful drive chain. It became apparent early on in the restoration that if the hull was not protected from the elements, it would rust away and ultimately collapse. Using an innovative technique with which the great man himself would surely have approved, the restoration team sealed the hull by fitting a glass plate at the waterline and installing dehumidifiers below. This keeps the air around the hull as dry as the Arizona desert, preventing further deterioration. Things had moved on since his first ship, the Great Western. Going into service in 1845, the SS Great Britain was the first double-skinned, iron-hulled, steam-powered, propeller-driven ship afloat. And she was ahead of her time. During her life at sea, she travelled over 1.25 million miles, and one of her many tasks was to ferry troops to the Crimean War. The Crimean War broke out in 1854, whilst Brunel was engaged in the building of the Great Eastern. His brother-in-law, Sidney Herbert, was Secretary of State for War, and he was receiving alarming messages from the front, suggesting that more soldiers were dying due to lack of medical facilities than at the hands of the enemy. The government needed to act quickly. For a practical solution, Sidney Herbert turned to Isambard, who he charged with the task of designing a hospital. Nothing remains of that hospital except drawings and record, which show that he designed a fully functional 1,000-bed hospital. His total package took into account ventilation, drainage, lighting and sanitation. The buildings were wooden and prefabricated and shipped to Turkey for erection on site. From the start of design to the hospital becoming fully operational took just 5 months. Alongside all his other work, Brunel continued with the expansion of the railways further into the southwest. The steep terrain beyond Newton Abbot on towards Dartmoor caused him to question whether steam locomotives would have the ability to cope. He had heard of the largely untried atmospheric propulsion system as a solution to this type of problem and decided to try it out in the first phase between Exeter and Newton Abbot, part of which ran close to the sea. The concept was simple. A cast iron pipe with an open slot along the top was laid along the centre of the track. A piston was fitted inside the pipe and it was connected through the slot to a wagon that was used to pull the rolling stock. The slot was made airtight by means of a flexible leather seal. Steam pumps were placed in buildings, like this original at Star Cross, at intervals about every 3 miles along the track. As the pump sucked air from the front of the piston, the natural pressure of the atmosphere pushed from behind and the train moved forward, rather like drinking water through a straw. However, the impact of the salt water and temperature changes meant that the leather seals failed to keep the pipe airtight. This leak caused the loss of the vacuum, the pressure in the pipe equalised, and the train stopped. In less than a year, the experiment was abandoned, and Brunel was sadly disappointed. However, whilst this was a setback, it most certainly did not stop the extension to the network. The line needed to be pushed on into Cornwall, and this required the difficult crossing of the Tamar estuary. The resulting Royal Albert Bridge at Saltash took 10 years to complete. Consisting of 2 450 feet iron trusses supported by one central pier, it proved to be one of Brunel's finest achievements. When it was opened by Prince Albert in 1859, crowds flocked to see it, but Brunel was not among them. He was too ill. Too much work, too many cigars, and a bad accident were taking their toll. This amazing man who had achieved so much was dying. His death 4 months later, on the 15th of September, shocked the nation. He was just 53. His name was placed on the Albert Bridge as a lasting tribute, and this bronze statue was erected on the Victoria Embankment in London. He had led the way in an engineering revolution that changed the face of not only this country but the world, and not only during his lifetime but forever.